Okay, so for the rest of the morning, I'm just going to try not to do any MATLAB shaming, but just present a case for why you might think about using Python if you don't already. And then Yarek will give an overview of some of basically reproducibility and some open science tools that he's been involved in developing. And then we'll have lunch, and then we'll move over to the other space and then do some more hands-on stuff. Okay, so the pillars of open science. This is from a review paper from Russ Pold. Yeah.
Are these slides available on Instagram?
They will be available. Yes. Yeah. We'll have a link on the website with the videos. It's basically the pillars of open science, and that there's kind of different parts. So there's open publishing, so being able to not have to pay to publish it and then pay to download the same paper, and then also being able to share your code, and then also data. And there's many more things of open science too, but I think these are ones that we talk about a lot. So for me, I'll just say I use MATLAB for about 15 years, and I would use it for neuroimaging. I did it for when I was using computational modeling. When I wanted to do statistics, often I would switch to R, and I used that for about 12 years. And plotting, I would spend pages of code on ggplot making really nice figures. And in scripting, well, neither MATLAB or R was great for that, so I would use Bash. And then there was these awesome things called awk and sed, which were invented in the 60s and 70s. You're lucky if you didn't ever have to use these. And basically, I have switched, and it was not willingly switching from MATLAB to Python. One of my collaborators, Tal Yarkoni, basically said he wouldn't work with me on a project unless I did it in Python. And he was kind of joking, but kind of not. And I just wanted to put this up because I saw this tweeted last week about this is a case for MathWorks on their website for why you should use MATLAB over Python. They're trying to sell you on why you should buy their product over the free one. And the difference is clear. MATLAB is the easiest, most productive computing environment for engineers and scientists. Includes the MATLAB language, the only top programming language that's dedicated to mathematical and technical computing. They have a whole list of reasons why you might want to do this. Basically, what I found is the switching costs are bad in general if you're trying to go between different languages, and it gets worse when you're a professor, when you're also switching between teaching and service and traveling and everything. And then I'm like, oh man, how do I load data? And then I would spend 15 minutes doing that, and that was my 15-minute block of time when I could work on something. And then I'm back to email or teaching. It's also very expensive. So I have colleagues at institutes that aren't affiliated with universities, and they actually have to pay for their MATLAB licenses and for every package that they want to use. And for one of them, it was so expensive, they all collectively decided they were going to switch to Python and use that money to buy a cluster instead of doing their annual MATLAB license. Also, when I first moved here, it's now since changed, but the original network authentication for our university site license was network authenticated. And in New Hampshire, you guys are lucky you're in the big city. You're downtown Hanover. But further out in New Hampshire, there's no cell phone service or internet. It gets more dicey, and I couldn't load MATLAB in the beginning because of this. So I would have to use an old license from another university. Also, if you were on the plane, this was a similar thing that would happen. Obviously, this isn't the case everywhere, depending on how your license is. It's also hard to share code and packages with other people. And of course, you can send them your MATLAB code, and you could say, well, they could download Octave and run your code if the packages and everything worked. But it's a little bit different than if the software you use is free, so people who don't have a MATLAB license can still use it. It's also, MATLAB is really hard to deploy. These are all personal experiences, by the way. It's really hard to deploy on cloud computing. So if you want to have auto testing run or auto documentation, or if you want to have like analyses being run on different things, you have to have different licenses, and your site license doesn't include Amazon and things like that at the university. Exactly, you can, as long as you don't get caught. You can't automate GitHub webhooks, which we'll probably talk about this week. It doesn't play well with containers, so we'll do a tutorial on containers this afternoon, and our MATLAB is not in that. We have to do it separately because of the licensing issues. And it used to be, and I think it's the industry jobs and trends have changed a lot, where it's not as useful as it used to be, especially in the data science world, where R and Python are, I think, easily taking over that space. And for me, the biggest motivation for my learning, so I basically switched to Python right when I was starting as a professor here, and it was because when I thought about what I wanted my students to learn and what types of careers they're going to have, I was like, is it crazy that I just keep using all my MATLAB stuff and they leave and they have to use it, but then if they don't want to stay in science, then all their skills that they spend a long time developing, is a good use of their time. So that was kind of the biggest impetus for me to switch personally. Okay, that's still not like compelling enough. This is a little dated now, but Talia Coney wrote a nice blog post on the homogenization of scientific computing. I actually looked at it this morning, and it's 2013, so it's a bit old, and it's funny because there's like, there's this cool package that came out, and it's like now the dominant one. And then there's another nice talk by Jake Vanderplas at PyCon a year or two ago on where he tries to make, this is for like Python developers, but why Python is like really nice in the scientific domain. And then also, there's these fun personalities of Python evangelists. So you might see some of them around. So we have our own Yarek Palchenko, who you'll hear from in just a minute. Chris Gorgluski, Talia Coney, Satra Ghosh, and Kyle Verikal. These are all people who are really active in developing tools that we use. And they're like very lovely, and they're go out of their way to help people. So if you ever have questions, like Sasha in the middle of the night will write me back if I have a problem with something, and he'll give me a solution. And just very, very generous with their time. It's also becoming popular. This is also a little dated. This is from last year, but if you can look by GitHub, you can do Google searches, and basically Python is just becoming much, much more popular. And it's partly because of data science, but it's also because it's used often in web development and many different applications. So all those different communities together combined are becoming, contributing to this trend. So why is it so successful? So it has a high-level intuitive syntax. People have mentioned that it's not C, so the execution speed maybe isn't fast as if you had written C and compiled it. But then on the other hand, it only took you 2 minutes to write this little bit of code, where it might have taken you, hours or days to write a lot of C code for it. It's a real programming language. I don't know what that means. But it's basically meaning and if you've ever tried to work with strings in MATLAB, for example, that's difficult. It has object-oriented and functional programming constructs in there. It plays well with other things, so you can have bindings to other languages. I actually thought this was really irritating in the beginning, but it has very opinionated style guidelines, which MATLAB and other languages don't. And why is this irritating? Well, I don't know how to program. I never took a computer class, but I certainly didn't like people telling me, oh, you don't want to do that. You want to not use underscore. You want to capitalize this or whatever. But the advantage of it is when you start reading other people's code, especially in the scientific computing community, it's really easy to read their code because people use the same style, and also it makes everything play well with each other. And yeah, anyway, there's lots of benefits to it in the longer run. Jeremy might talk about that a little bit more in the afternoon. It also has a really tightly integrated software stack, especially for scientific computing, which I'll talk about in a second. And then for me, I think the biggest selling point has been it's like one language where I can use lots of stuff. So I use it for teaching, I use it for data analysis, I use it for scripting. We write a bunch of web applications, many of them are in Python, on the back end at least. And best, it's free. So there's a few other bonuses. This was not the case when I started, but it's gotten a lot better, where there's relatively easy package management. This is compared with MATLAB. It has fantastic ways for you to build documentation automatically using a package called Sphinx. There's lots of automated testing packages, but PyTest is one that's become really popular. And then there's really nice libraries for doing parallelization, and so multiprocessing in Joblib builds on that. And then Dask is a new one that's really exciting for doing out-of-core stuff. So if you have stuff that won't fit on one computer, either in RAM or in CPUs, and basically you can use your normal Python code, and then it'll try to use what it can, and it'll swap it out with other things if it doesn't work on your system. Okay, so what does the scientific computing platform look like? And this is very imaging specific. So there's this Python core, and if you're going to start, I would recommend just starting at Python 3. Don't even, Python 2, legacy Python will be deprecated, I think, in a few months. So just don't even bother with it at this point. Then there's a bunch of packages that are built on it. So NumPy is the MATLAB plugin for Python, and SciPy is a bunch of MATLAB packages, essentially, for optimization and many other things. Jupyter, this is an interface to deal with clusters, but also to do, you basically can interact through a web interface with a Python kernel. And then Cython, there's ways where you can speed it up, and it'll start typing things and make it run faster, so it's closer to C speeds. Then on top of those, there's more things built on top of it. So Pandas, this is R data frames. Matplotlib is plotting in MATLAB. And then there's a stats model package, which has lots of regressions and different types of time series and modeling. Multilevel is one for loading imaging data. And then there's symbolic Python. And then on top of that, there's even more packages built. So scikit-learn has become a pretty industry standard for a lot of types of machine learning models. TensorFlow was released, I guess it seems like it was a long time ago, but I think it was only maybe about 2 years ago. And it's basically a framework to build deep neural networks. And they do a lot of like the hard work for you of like how do you compile this onto a GPU or CPU, or how do you, they extrapolate a lot of the stuff that's annoying. And then there's even ones built on top of TensorFlow, for example. There's graph ones like NetworkX. There's this amazing toolbox called HyperTools that was developed here at Dartmouth in Jeremy's lab. Seaborn is a really nice visualization that's high level that's built on top of map.lib. There's probabilistic programming, and then NiPipe is a really nice pipelining thing, where if you want to have like a whole set of steps to your data of pre-processing, it's constructed as a graph, and then it'll deploy it on a cluster, and it'll automatically figure out what you need to run and how it should be distributed. And then on top of that, there's even more stuff. So Brainiac is a really nice imaging library that's being developed at Princeton. NiLearn is an excellent one that's developed by Gaël Verrequois in France. IVPA is looking long in the tooth, but it's hopefully going to be revamped soon. That was developed, I guess, at Princeton and at Dartmouth. And then there's a MNE, which is a nice one that's part of the scikit-learn developers, were for more doing EEG and MEG. And then Neurosynth is another kind of meta-analysis software. There's actually a new one coming out that's also in Python as well. Okay, so something for everyone. So if you're coming from MATLAB, NumPy and Matplotlib are going to feel very familiar. A lot of even the syntax is quite similar. And if you're coming from R, Pandas is similar to R data frames, although it has other things as well now. There's things called like RPy2, which is a package where you can work in Python but call R functions and send data to and from R. And like one thing that I'll concede on this that Python still needs some work on is there's not like a great mixed models if you do multi-level modeling package types of analyses in Python yet. There's one that's a Bayesian version of it called Bambi. It's really nice, but it can't do all types of random effect structures. It's a little slow. Eshin Jolly, who you guys met this morning, has written a nice interface that's like a high-level one where you're working with Python, but it's actually calling R in the back end, and he's kind of slowly porting everything over to Python, so it will call R less. Right now, I actually wouldn't recommend using stats models if you're doing this, even though they have mixed effects, but I found the results to be, it doesn't validate that well with other packages yet. Okay, and then the really nice thing, even though this isn't Python specific, because you can do this in MATLAB or R or anything, but there's this nice initiative to move towards these interactive computational narratives frameworks. So there's Jupyter notebooks, there's a Colab one, I can't remember what the Microsoft one is, but they also have their own version, Azure or something. And the idea is, it's really cool, so you can have, it basically will, if you run on your local computer, it'll spool up a server that you access through your web page, and then you can type in commands and then run it, and then you also can do markdown, so you can basically do a whole series of like what your analyses are. And so my students do this, and they'll send me a link so I can see what they did and what the results were. It's all embedded, and also little narratives of what they did. What's also really nice is that server doesn't have to be on your local computer. It can be in the cloud or anywhere. So in the classes that Jeremy and I have been developing for our undergrads, we actually run something called Jupyter Server, which runs on our cluster. And then the students log in, they have an account, which will, so they don't have to install Python or anything. We've already installed an environment that has all the packages. And then they can run it from their laptop, and then all the data and computational resources on another computer. And the Google and Microsoft versions of this, you get some free, but if you want to pay, then you can use their cloud computing. So they have similar types of things. Okay, so if you haven't started yet, one place, so people debate about this, but I personally find that Anaconda is a nice way to get started. They have a scientific computing thing where if you download it, it's a little big where it has a whole bunch of packages that I think you'll need, and then you can install other ones on top of it. They've made sure that all the packages work well together. And it's a for-profit, but they distribute this for free. There's a bunch of really nice resources to get started in Python now. So Jake Vanderplas has one called Whirlwind Tour Python, which is like an online book. He has a real book, it's an O'Reilly book called Python Data Science Handbook, and the whole book is available as a Jupyter notebook, so you can download it and run it interactively for free. This is a class that was developed by Yark to teach graduate students here in Python. This is one that I've developed for undergrads that's teaching how to do neuroimaging analysis, all from Python. And then this is one that Jeremy just taught on, it's also an undergrad data analysis on storytelling of data. And it has like kind of intro Python stuff, but then also more specific to data analytics. Okay, that's all I got for this. Any questions about this?